we're going to use AI and time travel debugging to explore the Doom source code and understand exactly what's going on under the hood. What I've done is, while playing Doom, I've recorded the entire execution of the process with Undo's live recorder tool. And what this has given me is an instruction precise trace of everything the process did. That means I've got every line of code that executed, every thread that ran, every variable, every memory location. So we can query from this any arbitrary information about the program's execution we want. The first thing we're going to do is, using this frame viewer in the top right of the screen, we're going to have a quick look through my fairly amateurish playthrough of the shareware Doom level. I'm running this in Chocolate Doom, which is an open source Doom codebase that tries to stick quite close to the spirit of the original code. What you can see here is me playing through the level, trying out different features of the game, and eventually coming to the end of my playthrough, at which point we save the recording. So here we are. I saved a recording at this point in time, and we can review anything that happened within the game's code during the period we just viewed. What I'd like to do now is show how to explore, using AI, exactly what happens in the Doom source code, and to understand it from a high level. So we actually want to use AI plus time travel to understand the semantics of what the program was achieving, not just what the raw lines of code did. So I'm asking here for our AI extension, explain, to tell us when the second zombie was killed in this playthrough. When this happens, it fires up a coding agent as its engine in the background. We're using Claude Code in this instance, and it turns over control of the time travel debugger, UDB, so that the coding agent can actually drive it, move around in the recorded program history, and explore an attempt to answer our question. So first of all, it tries this variable total kills. Then it finds the players array and it tries this variable kill count. And what we're seeing here is the AI agent navigating through history based on the values of these variables. So it can skip directly to interesting changes in the data, which is often quite a good way to understand what a program's achieving. Because we've got a deterministic recording of the program, we've effectively got safety rails here. The AI can't disrupt a live debugging session that I'm doing. It can't mess up the state in the program. It can only review backwards and forwards through what's already happened and what's already been recorded. So we're providing here a ground truth for the AI coding agent to work with. We're seeing in the top right what was on the screen at the precise moment the coding agent is currently expecting. We can see here, it looks like it's found the second zombie kill in the game. So it's answered the main part of our question here, and what we're now seeing is the AI agent exploring some more state that relates to these points in time. It's free to travel back and forth between the points in time. It's found interesting, collect more information that it believes is going to help contextualise what it's found and provide us with a good, comprehensive explanation. So here it's collected information about the second kill, and it's now revisiting the earlier bookmark it made at the first kill, and it's collecting contextual information for that. This capability to bookmark and return to an earlier interesting point in time gives it the ability to recover from failed investigation steps or to explore at its leisure anything that it thinks it might need to follow up later. We now have a summary, so we can see, based on our investigation here, it's got the time that the second zombie was killed in various units, it's got the location, it's confirmed that indeed this was a zombie type enemy, which is a MT possessed in the Doom code. It's also given us comparison of when the first zombie kill happened. This looks about right as well. It was about 1.4 seconds between the two because they're in the same room. And this is our answer. So we've been able to work backwards to a comprehensive explanation from just a recording and the help of our AI agent, and it's created bookmarks within the recording which we can use to verify the AI's reasoning or as a jump off for further investigation.